Okay, 4.7 and 4.8 are the last two sections in Chapter 4. I have these combined since really the topic is just more equation solving. There's a couple of different kinds of equations that we'll solve here in these sections. A rational equation is one type. A rational number is just kind of fancy words for a fraction. So a rational equation would be an equation that involves a fractional form with some of the terms. So I want to solve this equation for x. Here's an example. And the first thing that we usually want to do when we are solving a rational equation is we'd like to clear out the fractions. In this problem here, in order to clear out all the fractions, I could multiply both sides by x plus 3 times x minus 3. X plus 3 times x minus 3 is the same thing as x squared minus 9. And that would be in common to the denominators here on each of these denominators for these fractions. So if I multiply both sides by x plus 3 times x minus 3, when I distribute x plus 3 times x minus 3 into the first term here on the left, the x minus 3's will cancel. That's going to leave me with the 1 that's in the numerator, also the x plus 3 that's still coming into that first term in the numerator. And then when I distribute this into the second term, 1 times x plus 3 times x minus 3 is x plus 3 times x minus 3. On the right, x plus 3 times x minus 3 is x squared minus 9. So I've got x squared minus 9 going to cancel with another x squared minus 9 up top. And that'll leave me with just the 6 that would be left over there up top on the right. And so the next thing is I'm going to get all the terms onto the left. And now you'll see that I no longer have fractions, which is nice. It's kind of more on familiar ground here. And solving a quadratic, this one will factor nicely, and it looks like x equal -4 and x equal 3 would be the two solutions. Okay, now one thing about a rational equation is that you have to check for extraneous solutions. It can sometimes happen where a number comes up that's not actually a solution to the equation. And so at this point we're saying that -4 and 3 may or may not be the right answers. We don't know, we got to check. Now 3 is an extraneous solution because when you plug that back into the original, there's going to be a problem with division by 0 here. So that number came up in the calculation. We would want to throw that away. Now, really in the check procedure, the only thing that you're looking for is that you're not going to divide by 0. We know division by 0 is not allowed. -4 is not going to create 0 in the denominator of either of these two fractions. If you wanted to completely check that -4 is indeed correct, I've done that here. You'll see that 6/7 is the same as 6/7, or that's the same number that you're getting on both sides of this equation. Therefore, -4 would be the only answer there. Okay, here's another example. Again, we're solving for x, and again, we want to get rid of the fractions that we see pretty much right off the bat here. We can do that by multiplying both sides by x minus 1 times x plus 2. And now x minus 1 times x plus 2, that's the same as x squared plus x minus 2. So we're going to conveniently have all of these denominators go away on both sides. That'll sometimes happen with the equations that you guys have. And so I've got x squared plus x minus 2 going to cancel with x squared plus x minus 2 right here. That'll leave me with 9 on the right. Now on the left, when I distribute x minus 1 times x plus 2 into the first term, the x minus 1's will cancel. That'll leave me with the 3 that was in the numerator. Also, I've got x plus 2 still coming into that first term in the numerator. And then when I distribute x minus 1 times x plus 2 into the second term, the x plus 2's will cancel. That'll leave me with the 7 that was in the numerator, and also the x minus 1 that's still coming into that second term there. When you distribute and collect your like terms here, I'm getting 1 as the value for x, and 1 is not going to work because when you plug that back into the original, there's a problem with division by 0. 1 was the only number that came up, didn't work, so this equation is going to have no solutions to it. Okay, and then here's a third example. Again, we're solving for x, and we want to get rid of the fractions right away here. X times x plus 1, we'll be able to get rid of all three of these fractions. X times x plus 1 is x squared plus x. So you've got x squared plus x right here, and an x squared plus x right here. Those will cancel, leaving you with 1 on the right. On the left, when you distribute x times x plus 1 into the first term, the x plus 1s will cancel. That'll leave you with the 4x plus 3 that was in the numerator, also the x that's still coming into that first term, plus when you distribute x times x plus 1 in the second term, the x's will cancel. That'll leave you with the 2 that was in the numerator, also the x plus 1 that's still coming into that second term there. Okay, and then when you distribute and get everything onto the left, you'll see that we're looking at a quadratic equation now. And so we're back on more familiar ground here than we were before. This quadratic is going to factor nicely, and when you solve for x, you're getting x equal negative 1/4 or x equal negative 1. We can see again that negative 1 is going to be a problem in that we can't divide by 0, so that number is extraneous. We'll throw that away. Negative 1/4 does not create 0 in the denominators of either one of these three fractions. Again, if you wanted to completely check to make sure that you're getting the same number on both sides, you could do that. I've done that here. Negative 16/3 equal negative 16/3 is true. You're getting that same number there on both sides. So x equal negative 1/4 is the only solution. Okay, another type of equation that we need to solve here is called a radical equation. And we'll be working with the equations that would involve a radical such as a square root or a cubed root or something like that. Here's an example, and I want to solve this equation for x. Now, the plan early on with this should be to try to get rid of the radical. Okay, to do that, you want to get the radical all alone and on one side. So I'm subtracting 5 here to begin, and then to get rid of a square root, you want to square both sides. When you square a square root, those two operations kind of offset each other and leave you with the expression that was underneath the square root sign. Be sure that you square both sides. Okay, and when you FOIL out the right side and then get everything on one side, you'll see that you no longer have any radicals left, which is good. That's what we wanted. We've got a quadratic here at this point, and we want to factor. This one will factor nicely, and when we set the factors equal to 0 and solve, we're getting x equal 9 or x equal 2. Now, a radical equation is another kind of equation where we have to check for extraneous solutions. So again, 9 and 2 may or may not be the right answers. We don't know. We'll have to check them. If I just do a quick mental check with 2, 2 plus 7 is 9. The square root of 9 is 3. 5 plus 3 is 8. And 8 is not equal to 2. That would be false. So 2 is extraneous. I would want to throw that away. 9 is correct because when you plug in 9, 9 plus 7 is 16. The square root of 16 is 4. And 5 plus 4 is 9. 9 would also be the number that you're getting on the right side. 9 equal 9. That's a true statement. Now there are only three kinds of equations in all of algebra that you need to be checking your answers for extraneous solutions. They are a rational equation, a radical equation, and then the other one we'll look at later on when we talk about logarithms. Okay, here's another example. I've got a radical equation and I want to solve for x. Now here I've got a what's called a double radical equation because of these two radicals that are there. And the best way to solve a double radical equation is to get one of the radicals alone. It's not going to matter which one, and then get rid of that radical. And then later on in the calculation, you'll get the other radical alone and get rid of that other radical. Okay, that's going to be your most efficient option. So here I'm starting by getting the square root of 3x plus 1 alone on the left. And I've added this radical to the right here. And now I want to square both sides. So when I square the square root of 3x plus 1, I get 3x plus 1. That radical went away. That's what I wanted. And I'm squaring both sides. Of course, I would want to FOIL this. Some students will make the mistake where they'll want to bring in the power of 2 into these two terms, and they'll say 1 plus x plus 4. Don't do that. You can't. You can only bring in a power when you're multiplying or dividing, not ever when you're adding or subtracting inside the parentheses. So when I FOIL here on the right, 1 times 1 is 1. In the middle, I've got the square root of x plus 4 plus another square root of x plus 4. That's 2 times the square root of x plus 4. And then at the end, the square root of x plus 4 times the square root of x plus 4. That's the square root of x plus 4 squared, which would be the same as just x plus 4. So now you'll notice that we only have one more radical here. And so we'll plan to get that all alone coming up. If I subtract 1 from both sides, those terms are gone. I'm also subtracting x and subtracting 4 from both sides to get to this line here. You could divide by 2 then to get to the next line. And so now I want to get rid of these the other radical by squaring both sides. So the square root of x plus 4 squared would be just x plus 4. And then, of course, you're squaring both sides here, so you'll want to FOIL out the left. And when you FOIL out the left, x minus 2 times x minus 2 gives you x squared minus 4x plus 4. And now you'll notice that we no longer have any radicals, which is good. That's what we wanted. If you get all the terms onto one side and factor out an x here, x equals 0 or x equals 5 would be the possible solutions. Again, we'd want to check that. 0 is not going to work because if you plug 0 into the original here, you'll have the square root of 1, which is 1, minus the square root of 4 is 2. 1 minus 2 is negative 1, not positive 1. So you're not getting a true statement there when x is 0. If x is 5, I think it's all good because 3 times 5 is 15, plus 1 is 16. The square root of 16 is 4, minus 5 plus 4 is 9. The square root of 9 is 3. 4 minus 3 is 1. That is true. And so 5 is going to be kept. 0 would be extraneous. Okay, and here's another example. So here I've got another double radical equation, although I'm not adding radicals. I've just simply got a radical on both sides. So this equation is going to be handled differently than the last example. I can actually get rid of the radicals right away. Now when I have a square root, to get rid of the square root, I square both sides. When I have a cubed root, to get rid of the cubed root, I cube both sides. So I would begin by cubing both sides, and that makes the radicals go away on both sides, which is nice. Subtract x, and now I've got a quadratic. This one is going to factor nicely. Okay, and when I set the factors equal to 0, I get x equal 4/3 or x equal 2. Both of those are going to check. Here I've got my check procedure on that. So if I plug in 2, for instance, 2 times 4, 2 is 4, 2 squared is 4, times 3 is 12, minus 8 15 is negative 6 plus 8 is 2, so I get the cubed root of 2, which is what I would have there on the right. Here's also the check procedure for when you plug in 4/3. You can see I've gone through the calculation there also. Okay. I had another group of equations that we're going to actually omit here. This is, I guess, nice equations to know how to solve, but they're not really essential for making or breaking an algebra student. So I'm going to skip equations with rational exponents or negative exponents. Here are the homework problems in the book. You do not need to know how to solve equations that have either negative exponents here or fractional exponents. I won't ask you that on an assignment.